Okay, I wanted to go over a few examples of how to go about a numerical approximation to area under a curve based on the lecture we already had. And the notes are already provided for you. So what you'll see here is all the notes for the left endpoint rule and the right endpoint rule. The formula, here's my right endpoint. We talked about this in class, and here's my formula here for the right endpoint. This is the R of n that we already discussed. You guys know all about it. Similarly, we have a formula for the left endpoints. And as you can see, we have all the left endpoints there. This is again discussed in our lecture. We have the formula for the left endpoint rule. And of course, the midpoint, the most accurate. You got these midpoints there. And so this is all part of our lecture already. And you got the midpoint rule. And what I wanted to go over is some more demonstrations of some examples. So remember, go back, left endpoint rule, right endpoint rule. Start with the right endpoints. All the right endpoints are down here. x1, x2, xi minus 1, xi, xn minus 1, all the way up to xn. These are the right endpoint values for the right endpoint rule. Again, with its formula. We'll use that. Compare that to the left endpoints. x0, x1, x2, xi minus 1, xi, all the way to xn minus 1. We're going to see that again illustrated, where I goes from 0 to n minus 1. And then, ladies and gentlemen, you got the midpoints again, m1 through mn right here, all these midpoints of every interval with its rule. So the notes are there, where the lecture was there. You already had an example as well. Let's see an additional example. Now, this is how we go about this. We're going to look at how to find the area under the curve here over the interval from -1 to 1 here. So this is the area that we are looking to approximate now. And the function they give us is right in here. This is the function. It's 1 over 1 plus x squared here. So here's how you always start these kind of questions. This is important to start. We need the partition. And in order to get the partition, you need your delta x. And the delta x here, the length of every subinterval, is the length of the interval over the number of partitions. So they gave you the number of partitions here. They said with 10, 10, 10, that means they want 10 partitions. They want the value of n to be 10, so I have this 10 value. Now, a and b here, this is a, here's is b. So this is 1 minus a -1. So we get 1 plus 1 over 10. Which is 2/10, better known as 1/5 or 0.2. So our delta x is going to be 0.2. That's the difference. That's the delta. That's the length of every subinterval. So if you're saying now, what about L10? So for L10, the question is, well, where do you start, right, in L10? Let me double check here. We're going to probably need more space, but L10, remember how this works, right? If the first endpoint is -1, this delta x is 0.2. This would be, add the 0.2. This will be 0.8 and -0.6. -0.4, -0.2, 0. And as you can see, we're going to need more and more points here. So this will be 0.2, 0.4, 0.6, 0.8, and 1. So let's move everything here so it kind of looks somewhat presentable. So this is for L10. Now this is going to be my x0, x1, x2, x3, x4, x5, x6, x7, x8, x9, and x10. So for the left endpoints here, the left endpoints, these are the values for all the left endpoints. It starts at x0 and it ends all the way to x9. The value of the function is 1 over 1 plus x squared. Okay, so this is the value of the function. Now what I'm going to try to do here is I'm going to get this scratch work here. I'm going to copy that. And I'm going to go to, hopefully we have, this is the notes from the other day. I'm going to use that portion here. Because for the left endpoint, L10, remember that's the sum where I goes to 1 go back to the definition. Right, left endpoint row. Right, I goes from 0 to n minus 1 here. So I goes from 0 to n minus 1, which will be 9, f of xi delta x, which will be now f of x0 plus f of x1 up to f of x9. And I guess I'll give you every detail again. Remember, that's a delta x there. And that's a delta x there. And that's a delta x. But we can factor out the delta x. So this is simply the sum now of these left endpoints up to f of x9 with your delta x. So you need the endpoints. And the first endpoint was -1. The second endpoint was -0.8, and so on. -0.6. All the way up to 0.6 and then 0.8. And that delta x at the very end is 0.2. So we had the delta x earlier. We got to be 1/5 which is 0.2. Okay. So we need now to remember what the function is here. Now, there's a couple of ways I can do that. So maybe I'll just write that down here and say this is 1 over 1 plus -1 squared plus 1 over 1 plus -0.8 squared. Okay? All the way up to 1 plus positive 0.6 squared, 1 plus positive 8 squared times 0.2. So what you are seeing here in every one of these is that value squared. All the way up to that delta x of 0.2. So I'm going to color this purple maybe, so it stands out so we never forget that value. But what I wanted to really demonstrate to you, which is kind of important as well, is like in the TI here, okay, let's go back there. In your TI calculator, so when I go to the TI, I want to make sure I'm strictly looking at this TI. There we go. I want to enter all this in my TI calculator because the value of the function is 1 over 1 plus x squared. So we want to enter these things here for you and see how this works. Now it's going to be a little bit cumbersome. I'm going to put parentheses here around each one of these in the calculator, I believe. Let me double check to see how this works for us, but here's what we'll do in the TI. Parentheses. Yeah, I can probably do it this way. Let's see. 1 divided by. Here's where I have a parentheses. 1 plus -1, close that, square it. And I think, yeah, nope. Let's go back. Parentheses. 1 divided by, we'll do 2 sets. 1 plus, here's the parentheses of a -1 here. Close that, raise that to the second power. There we go, and close it again. Here's what I wanted to do. So if I go back to the iPad, we entered that first rational function. We're going to have to add a 1 divided by another parentheses, 1 plus another parentheses, -0.8. Close that, squared. Close it again, and that's the second entry. So let's continue to do this pattern here. Okay. Plus 1 divided by, open that parentheses, 1 plus parentheses, -0.6. Close that, square it. Close it again. Plus 1 divided by, close this, 1 plus the -0.4, close this and square it, and continue all the way to +1. So now we're going to enter plus 1 divided by, parentheses, 1 plus -0.2, close that and square it, close our parentheses, plus the next one will be 0. So I guess we can put 1 divided by, parentheses, 1. I guess you can put plus 0 squared. Okay. Now it's going to continue at +0.2. Plus 1 divided by, parentheses, 1 plus 0.2, close this and square it, plus 1 divided by, parentheses, 1 plus 0.4. And I guess you don't really need a parentheses at this point because it's positive. So I'm going to just put the 0.4 squared. We kind of put the parentheses only when it's negative. So I'm going to just let you guys know we can do that too. Plus 1 divided by, parentheses, 0.6 squared. Oops, I forgot the 1. So let's go back. 1 plus 0.6 squared. Okay. Delete that. Close the parentheses now. So let's double check. Okay. Plus 1 divided by 1 plus 0.8 now. Square this. Close it. Plus 1 divided by 1 plus 1 squared. Close this and close it again. Now we went all the way up to here. The very last, oh, it looks like we overdid this. So let's go back and delete. We don't need the 1. Good. Delete. Delete. We don't need this portion. Delete this. Okay, we're going to double check. They're in the iPad all the way up to 0.8. So if you look at the TI now, we should end at 0.8. Okay, let's go back to iPad, calculator, end at 0.8. Now we close that parentheses here. We're going to multiply by 0.2. So this is everything you want to enter. It's everything you see here. 0.8 squared with the 0.2. Hit enter. We're going to go out to 4 decimal places here. Okay, they never told us where to go out to, but this will be 1.5675. Now this is going to be the left endpoint approximation here. So this is L10. So we got the left endpoint approximation, and that's good. We're going to repeat the same process now for the right endpoint approximation for R10. Now remember, for the right endpoint, we go from 1 to 10. F of xi delta x from 1 to 10. So this portion becomes f of x1 delta x plus f of x2 delta x plus f of x 10 delta x. I'm going to close that. We can factor out the delta x. We get f of x1 plus f of x2 all the way up to f of x10 with the delta x. So these are all the right endpoints now. And they're going to slightly vary now. In other words, you don't start at x0. Here you start at x1, but you end at x10 here. So the first approximation starts at negative 0.8. So you'll see here negative 0.8 plus negative 0.6 plus, go all the way down here, the last two, 0.8 and 1. So this will be 0.8 plus f of 1 with this delta x here, bracket. So you're going to go through the same pattern here. 1 over 1 plus negative 0.8 squared plus 1 over 1 plus negative 0.6 squared. 1 over 1 plus 0.8 squared, and then 1 over 1 plus 1 squared. And then the delta x is 0.2. So we're going to go through the same process here. These are the x values. But these are going to be the right endpoint values. So this is what we have to very carefully enter in our TI calculators to approximate. Right? So we're going to put a parentheses again and another parentheses. I don't think, did we need that one? No, we didn't need that one, right? This is 1 divided by a parentheses. 1 plus the first approximation is a negative 0.8. Parentheses negative 0.8. Close that and square it. Close the parentheses again. That's the first approximation. Plus 1 divided by, parentheses, 1 plus negative, let's go back to the negative, 0.6, square that there, and you close this one. Plus 1 divided by parentheses, 1 plus, another parentheses, negative 0.4, close this and square it, plus 1 divided by 1 plus parentheses negative 0.2, close that and square it, close your parentheses, and now we're going to be at 0 again. Plus 1 divided by 1 plus 0 squared, close that, plus 1 divided by, parentheses, 1 plus after 0 is 0.2. And we don't need a parentheses there because we only put a parentheses around negative values to emphasize they're negative. Close that. Plus 1 divided by, parentheses, 1 plus 0.4 squared. Close that. Plus 1 divided by 1 plus 0.6 now squared. Close this. Plus 1 divided by, parentheses, 1 plus 0.8 squared. Close this, and we're going to end with the last one. Plus 1 divided by, parentheses, 1 plus 1 squared, and close this. Now you close it twice because you got to multiply by the delta x, which is 0.2 in this case. So ladies and gentlemen, double check to see if what we have on the iPad, where we start with that x value and where we end with the x value is where it should be. It should be within that calculator here now. So we can now hit enter. We'll approximate this one now as well. And that looks to be pretty close. It looks to be the same, which is kind of interesting. I mean, the calculator, that's kind of interesting. This would be R10, which is approximately 1.5675 to 4 decimal places, ladies and gentlemen. So that's pretty interesting there. It's just as a degree, you know, these are actually not as accurate if you actually went out to further decimal places. It's just as a limitation for the accuracy of your calculator here. But as you guys can see, we did enter different things there. So we didn't enter the exact same thing, but it's pretty interesting to me. Anyway, let's do M10. Now, M10, ladies and gentlemen, you guys know for M10, or I should say the midpoints now. We're going to do the midpoints in purple. So the midpoint here, we're going to start with the first midpoint, second midpoint. We're going to find all those midpoints. And maybe we should put it above since there seems to be some space here. Remember, I need -1 plus a -0.8 for the first midpoint, and I divide that by 2. So if I go to the TI now and say -1 plus -0.8, and I guess I can hit enter, but I have to divide by 2 here. Okay, so it's -0.9. That's my first midpoint. Now, I can add the delta x value. If you said, what do you mean add? I can take that -0.9, add my 0.2 delta x, and you get -0.7. So this will give me the second midpoint. And I could keep adding that 0.2. So it's -0.5, -0.3, -0.1, then you get 1.1, you get 1.3, 1.5, 1.7, you get 1.9. Now, these are going to be your M1, M2, M3, M4, M5, M6, M7, M8, M9. These are the M values. These are the midpoint values for every interval. We're going to now use these values to get a more accurate answer. And there you go. We're going to start with these values now. So that for M10, for the midpoints, let's keep the purple color. Is the sum of f of mi delta x. I goes from 1 to n, which is f of m1 delta x plus f of m2 delta x, all the way up to f of m10 delta x. And we're going to factor out the delta x now. F of m1 plus f of m2, f of m10 delta x. Those first values, negative 0.9 plus negative 0.7, all the way up to, I'll put the last two again if we go back, 1.7 and 1.9. And so we should start to put again 1 plus negative 0.9 squared, 1 plus negative 0.7 squared, 1 over 1 plus 1.7 squared, 1 plus 1.9 squared, and then the delta x in this case is 0.2. So ladies and gentlemen, this is what we're going to end up putting in our TI calculator here to approximate by the midpoint rule. So we're going to clear that out. I guess we can keep it. Parentheses. Here we go. 1 divided by 1 plus, in parentheses, negative 0.9, close that there and square it. Close it again. Plus 1 divided by, parentheses, 1 plus negative 0.7 and close that. You're going to square this. Close it. Plus, continue the pattern. 1 divided by 1 plus, parentheses, negative 0.5, square this, close it, plus 1 divided by 1 plus, parentheses, negative 0.3, you square that, close it, plus 1 divided by, parentheses, 1 plus negative 0.1, close this and square it. And we have a little issue. Let's go back and delete. There we go. Put our parentheses. Negative 0.1. Okay. There we go. Square. Close the parentheses. Now let's double check that we're okay. We get to continue. Now this is a negative 0.1. The next one will be positive 0.1. So 1 plus 1 divided by, parentheses, 1 plus 0.1 square. Close that. Plus 1 divided by 1 plus 0.3. Square this, and you close it. Plus 1 divided by 1 plus 0.5 and square that. Close it. Plus 1 divided by 1 plus 0.7. Square this. And we're at the last one. Plus 1 divided by 1 plus 0.9. Square that. Close it twice. And then multiply by delta x, which is 0.2. So, we can check what we're doing along the way to make sure we do everything correct. And hopefully we did. And it looks like we have a syntax error. Okay. Error. Let's go back and take a look. I wish we had to undo. So it looks like let's clear everything out. It looks like we have to, I guess if you hit clear, we hit clear. Where's the undo? Can we go forward? No, there's no undo. Oh my God. All right, let's try it all again. 1. Remember, what's the first endpoint? Got to go back to the first endpoint here. 1 divided by 1 plus negative 0.9. Okay. Square this. Close that. Plus 1 divided by 1 plus parentheses negative 0.7. Close that and square it. Plus 1 divided by parentheses 1 plus negative 0.5. Square that. Close it. Plus 1 divided by 1 plus parentheses negative 0.3. Square that. Close it. Plus 1 divided by 1 plus parentheses negative 0.1. Square this. Close this. And notice we did do a little mistake there. That's not a negative 0.1. So, delete. Delete. Negative 0.1. Close that. And now we square. All right, we look like we're okay. Okay. Plus 1 divided by, now it's going to be positive. 1 plus 0.1 squared. Close that. Plus 1 divided by 1 plus 0.3 squared. You close that. Plus 1 divided by 1 plus 0.5. You square that. Close it. Plus 1 divided by parentheses 1 plus 0.7. We square this. And we're going to end with the last one. 1 divided by 1 plus 0.9. Square that. Close it. Close that sum again. 0.2. Now I want to make sure in the iPad we end with 0.9, right? So let's go back. And hopefully everything's okay. We start with a negative 0.9. Then we go negative 0.7. 1.7 we end with, and 1.9. Yeah, it looks like it'll be, is it 1.9? Oh, we're not there yet. We got to continue all the way up to 1.9. Okay, so we almost did another mistake. So let's go back. Let's delete. Now here we go. Delete this. Here we go. Plus 1 divided by, that was wishful thinking. 1 plus 1.1 square this, close it, plus 1 divided by 1 plus 1.3 and square it, plus 1 divided by 1 plus 1.5 and square that, plus 1 divided by 1 plus 1.7 square this, plus 1 divided by 1 plus 1.9 square that. Now we close it twice. Okay, and multiply by 0.2. So it is always good to double check, like I just did, to see if we're starting with the right endpoints and ending with the right endpoints. Make sure you put your delta x, and then, you know, let's hit enter, and hopefully we get a very similar answer. And you sit there and you look at this, and we get a 1.893646. Who knows? All right. If you can find an error on this, ladies and gentlemen, please do. 1.8936. 1, 2, 3, 4. We should say 1, 2, 3, 4 endpoints. 1.8936, I guess. This is the final answer. And this should be M10, so it's kind of interesting. It's interesting what we got for L10 and R10. So double check, ladies and gentlemen. I wanted to share with you guys how to go about this, and hopefully, you know, you guys can get some of these answers. And there you go, ladies and gentlemen. So I hope you enjoyed the presentation here, and how you'll go about entering this in your calculator to deduce the approximate area under the curve. And there we go.